Hello, I am Joshua Maloney, and this is my presentation for Coastal Zone Management on the failure analysis of Texas Tower 4. I will describe the study, explore the scientific principles involved in its design and failure, list the ecological and economic impacts of the Texas Tower program, and discuss the results of the case study. The purpose of the 2002 case study was to see if modern ocean engineering technology and knowledge about storm forces could lead to a better understanding of current platforms in order to understand the causes of the failure of Texas Tower 4. The case study found that the failures were centered and initiated in the lack of prediction techniques to anticipate the extreme environmental loads, which led to insufficient design criteria. Their lack of advanced analysis tools and methodology to formulate the wave loads and structural response led to a design that had defects, especially including pin connections. The last major reason for collapse is the human and organizational malfunctions during installation, repair, operation, and the decision-making on evacuation, which contributed to the total loss of the platform and heavy casualties. The Texas Towers, named for their resemblance to oil drilling platforms in the Gulf of Mexico, were an innovative ocean engineering accomplishment. They served a legitimate purpose in America's defense. They were artificial islands with 300-ton steel deckhouses that served as housing for personnel, radio equipment, and the foundation for the Arctic Tower. Though the designers were provided the best oceanographic and marine geology information at the time, before the 1960s, little was known about wave formation. Probability studies established a criteria of 125 mile-per-hour winds and 35-foot breaking waves. In the 1950s, there were some theories that proposed that random pressure fluctuations in wind significantly generated wind waves. We now know that waves are controlled by wind velocity, wind duration, and fetch, or the distance over which wind blows. 3 engineering and construction companies bid on the tower construction. The DeLong Corp specialized in the design and construction of marine platforms and similar structures. They evaluated all of the problems with installing these structures at sea and formulated fair estimates for all 3 towers. Their estimation for TT4 was $1 million more than TT1 or TT3. They were different towers, so the DeLong Corp considered the logistical differences in installing the towers in 50, 80, and 185 feet of water. After J. Rich Steers Inc. outbid them by $1 million for TT4, DeLong testified that he assumed the lack of knowledge by the competing bidder led to similar estimates for TT3 and TT4. When the DeLong Corp saw the original plan for TT2, it had bracing between the legs. Mr. DeLong testified saying, "There is one thing we can all be sure of. The ocean is not going to get tired. You will get tired. A metal or anything else will tire before the ocean will get tired." The legs of TT2 went into the ground almost 50 feet. While TT4's legs, which held the platform 250 feet above the ocean floor, went into 18 feet of sand. Mr. DeLong later testified, "You are on awfully shaky assumptions that 18 or 20 feet is enough." While TT4 was being constructed on land, J. Rich Steers Inc. requested the Navy engineer to allow for pin tolerance increases. The design specified 1/64th inch tolerance, but they requested 1/16th inch for above water pins and 1/8 inch below water pins. Captain Foster, who oversaw the project from the Navy, approved all of these tolerance increases. TT4's legs were different than the other towers. Not only did they have below water bracing, but buoyancy struts in the legs allowed the leg and brace assembly to float across the ocean to its site. It floated on its A and B legs, while the C leg acted as the vessel's gunwale. During transportation, 2 braces broke off the legs and floated away. Captain Foster, oversaw the project from the Navy and approved the upending of the tower. New braces were specially fabricated onshore, and they were the same height and size as the original braces. They were pinned at the same way as the original braces, but attached to the legs by two half sleeves which formed a collar. A report in December of 1958 revealed that approximately half of the bolts were loose and could be extracted by hand. Divers reported that the bolts were not of design, diameter, or length, and that some of the holes were oversized. From the time the Air Force took over responsibility of the tower, the airmen had already nicknamed TT4 Old Shaky. On September 12, 1960, Hurricane Donna hit Texas Tower 4 with winds of 132 miles per hour and breaking waves exceeding 50-foot height. This exceeded all design specifications, and the tower was seriously damaged in the storm. The post-storm estimates that the overall strength was 55% what it was before the hurricane. Damage after Hurricane Donna forced the aircraft and its construction contractor to plan to begin to renovate the tower. The crew that remained with the tower was a volunteer repair crew consisting of 14 Air Force and 14 civilian personnel. The ecological and economic impacts of the Texas Tower platforms involve consequences during the tower's installation, operation, dismantling, and the continued environmental services the sites still provide. After Texas Tower 4 suddenly plunged into the Atlantic Ocean, the program's evaluation led to the entire program ceasing. There was never a plan to replace TT4, and the American Air Defense only increased the number of air patrols it already had to fly to fill in the gaps of the Texas Tower radar system. There were near immediate ecological impacts of the towers being installed at sea. An underwater inspection occurred on February 8, 1960, and revealed that each leg was heavily coated with marine growth and mussel beds to a depth of -90 degrees. The seafloor had about 6 feet of sand built up around each leg footing, and there was a considerable amount of debris on the bottom, namely 50-gallon drums, construction steel, blocks, and hoses. Here are the direct construction costs. Notice the construction cost of Texas Tower 4 was the same price as Texas Tower 3, and almost $2 million cheaper than Texas Tower 2. The annual operating costs show that Texas Tower 4 cost more money every year, and even though it was the shortest-lived tower, the all-year total was the highest. After the collapse of TT4, new policies were written, and if exceeding weather conditions were forecasted, the tower was to be evacuated down to a 7-member standby crew to guard against Soviet sailors attempting to board the platform and claim possession on the grounds of salvage rights. On January 15, 1963, TT2 was decommissioned and the legs were dynamited, and they planned to float the platform to shore. Just like Texas Tower 4, Texas Tower 2 plunged into the ocean and sank to the bottom. Salvage was not possible, and the structure still sits on the bottom of the ocean today. TT3 was decommissioned on March 25, 1963. Since the other two platforms had sunk into the ocean, the bottom deck of TT3 was filled with urethane foam and ensured it was watertight before they dynamited the legs. This was the only radar platform that was salvaged, and the other two remain as fish havens at the bottom of the ocean. The case study reported that the designers lacked the environmental prediction techniques, which led to insufficient design criteria, the use of pin connections over fully welded joints, and an underestimation of some of the extreme environmental loads. Current predictions of such structures automatically generate masses that include the hydrodynamic added weight of the water and flooded members. Design engineers omitted the 3,200 tons of fluids held by the tower. Therefore, their calculations were based on a structure weighing 7,500 tons, instead of 10,800 tons. It is likely that the design engineers overlooked the possibility of the legs buckling. The legs of Texas Tower 4 were different than the other two towers. In addition to the underwater braces, the lower part of the legs of Texas Tower 4 were used as ballast tanks during installation and fuel tanks after installation. This area was not reinforced with concrete, This section is the weak part of the leg, which broke near the footing during the fatal storm. The legs of Texas Tower 4 had an outer diameter of 12.5 feet and an 8-foot diameter tube extended from the top of the legs to 50 feet below the water surface. After damage acquired in Hurricane Donna, above-water X bracing was installed to stabilize the tower. This bracing went against the original design to keep bracing out of the wave action zone. The exact cause of the collapse of the tower is unknown, but the most probable cause of the collapse is the failure of the leg structure because of ineffective bracing between the A and B legs, which caused buckling of the B leg and shearing of the A and C leg. The wreck sites of TT2 and TT4 could be designated as marine protected environments based on the legacy of the sacrifices and the ecological benefits the underwater wrecks still provide. Thank you for watching my presentation. I hope you learned something, and please remember the sacrifices made. All photos are from Radome's Texas Tower Online Museum, and I suggest you view it.